Okay, a 80-metre lookout tower stands in the centre of the town. Two landmarks on the same horizontal plane are visible from the top of the lookout tower. The direct distance from the top of the look tower to the base of landmark A is 170, and the direct distance to the top of the lookout tower to landmark B is 234. The bearing of landmark B from landmark A is 105, and the bearing of B from the lookout tower is 142. So the direct distance along the ground between landmark A and landmark B is closest to. So because they want the direct distance along the ground, we probably want to set up the scenario that's on the ground. So here we've got point A, point B, and I might just call the bottom of the lookout tower C. Okay, so let's go to here and let's set that up. So when they're talking about bearings, we're talking about on the ground. So if we drew, say, we're going to draw a map version of that. So if we draw a map version of what's going on, so it says we've got landmark. So if we look here and we've got landmark A on the ground. So I'm going to do like I normally do, put my little compass, because it said here, it says the bearing of landmark B from A is 105. So I'm going to draw out 105, which would be out, say, this way, and I get to B. Okay, so and I put in my little compass, and I'm going to start putting things. So they said that this was 105 from landmark A. So you remember you're drawing from the north to the north. And so, you can, there's things that you can work out, and you might want to pop them in now if you like. And we know from here to here, because straight line was 180, so I know this must be 75. And if that's 75, we know that's 75, and things like that. So we'll just pop them in case it helps us later. All right, so let's have a look at the next piece of information where it says the bearing of landmark B from the lookout tower is 142. So we can see that we called the bottom of the lookout tower C. So maybe I'll put it up here and you see, and I'll put a little compass for it. And they said that it's 100 if we join the two. So I join B, the tower, and B, we can see they told us that was B is from the lookout tower. So we're going from the lookout tower is 142. So from its north around there is 142. So what are pieces of other little pieces of information we know? We know it has to add up to, we know this is 38 because a straight line has to add up to 180. So if there's 38, so if we know that this bit's 38, we also know that in here is also 38, okay, because of that one there and the parallel lines. So we're always trying to use these north lines as our parallel so that we can see when we have an intersecting line, okay? So in the end, so we've put in that information, and we what's the actual question asking is the direct distance between landmark A and B. So if I drew out like the triangle just a little bit separately, so we see what a bit more easier information, and let's see if we can put in. So I'm calling the bottom of the tower C, and we've got A and B, and they want me, obviously this is the question, little c, and so we need some other pieces of information. So let's see what we can get. We can actually get this angle in here because we knew from the north line to that red line was 75, but from the north line to here is 38. So that red dot in there must be the 75 minus that 38. Okay, so if we do 75 minus the 38, we get 37. So I know this is 37. So I know here is 37. Alright, so let's see, we must be able to get some other things. We've only got angles in here, so there must be a way to get some other side lengths. And what we're going to do is, it's up here when we think, they told me that the tower is 80 meters high. So here, I know that this is 80 meters. So this is like a 3D diagram. So if I drew just this scenario here where I have the bottom of the tower is C, and if I have the tower is 80 meters, and we come out along here, along the ground to B, and I know that if you join them directly, they told me it was 234. So right here, we can use Pythagoras because we've got two sides, and we could find out what this side is. And that side is between C and B, so that would be here on my triangle, that red triangle down the bottom there. So I could work that one out, and then if I draw the scenario over here where I have the tower that's 80 meters, so remember C is the bottom, and then the line that goes out to A, so this line, and we know that that direct distance is 170. So I could find out this this Z using Pythagoras, and that's the angle, and that will give me the distance between Z, A and C, so that would be down here. So we go off and we can do Pythagoras. So Pythagoras would equal, so you've got the hypotenuse, 170 squared equals Z squared plus 80 squared. And you're quite welcome to go and do the solve there, comma Z, and we find out that Z equals 150. Okay, and then if we do Pythag for our other one up here, we'll have 234 squared equals 80 squared plus x squared. So we use Pythag and we end up with x equaling, if I round 200, I'm going to round, it'll be 220 meters. So now I know that this is actually 220 and this is 150. So if you look at what we've got and we want to find C, okay, little c down here is the question. So now what have I got? I've got little side B and I've got little side A in terms of this triangle down here. Now, because I want to find, eventually I want to be able to find side C, so I'm thinking I'm going to have to first find this angle in here, angle C. So what I'm going to do is I'm going to use the sine rule. So I'm going to say, oh, well, I can't actually because I don't have side C. So I'm going to have to get another angle and I'm going to have to use what I've got. And I definitely have side B. So I have B and sine B. So I can use that. And I've got side A. So I'm going to use these two to find out this guy. And if I find out A, I'll be able to find out C. Okay, so let's go and we've plugged the data in. So we've got 150 over sine 37 equals 220 over sine A, or I might call this one X here. Okay, so if we remember on our calculator, we're going to put the solve in when we're finding an angle using the sine rule, and then we're going to set the restrictions for the degrees. So let's do that. Okay, so I'm transfer this onto a new page so I can keep working. So we've set this up and we're putting this on the calculator. Okay, so here's where we get our two sine answers. And here's where I'm probably gonna have a look and say, all right, because if I look in the diagram, that angle there, which is the x here, is it's less than 90 degrees. We can see in the diagram that it is. So I'm gonna go with this is my answer for angle A. So now, if I refresh up what we've got, so we know this is 37, we know this is 220, we know this is 150, A, C, B, and we now know, I'm going to round this and say 62 degrees, and I put this in as 62. If we know that is 62, then we know that in here must be 180 minus the 62 minus the 37. So, which we get, so I'll just do that, 180 minus 62 plus 37. So we get 81. So we now know that this is 81 degrees. And the original question is between the distance between landmark A and B. So for us, it's this little C. This is the question down here. So now I've got, I'm going to use the sine rule again, and I will use obviously C and sine C, because that's what I want to find out, and I'll use one that I've got, and I'll use the B over sine B. Alright, so I end up with, C is what I want to know, but I now know angle C equals B 150 over sine 37. Okay, and then we can just do solve, comma, C, and we end up with C equaling 246. So we end up with answer C. So this was the last question of the 2020 multi-choice exam for this unit, and hence there's a lot of work involved.